Atomic structure, all about the atom. So here we go. Atoms are able to be subdivided into smaller pieces, and we call those atoms. And every atom is unique to that element. For example, a gold atom looks in a piece of jewelry looks like the same as a gold atom in a nugget if found when you're dredging for gold. But they are super small. If we could take 100 million copper atoms and line them up in a single file line, it would only be approximately 1 centimeter long. That is very, very small. However, just because they're small doesn't mean we can't see them. We can actually use what's commonly called an electron microscope. And if you decide to go into chemistry, you will be able to use one of these in the college of your choice. I was able to use one at Georgia Tech once, and it's really neat to see atoms. Alright, so what we're going to do is we're going to get into the 3 subatomic particles. Sub, remember, means below, like submarine. Atomic is the atom. Particles just means little pieces. Dalton was pretty much right. The only thing he had wrong in his theory was when he said that atoms could not be divided anymore. What we know is that they can be divided up, and they are into 3 subatomic particles: protons, neutrons, and electrons. These are the fundamental particles, which means that there are other ones called quarks, but we're only going to really focus in on electrons, protons, and neutrons. And this is basically everything in a nutshell. We have electrons. It is abbreviated with an E with a negative symbol, sometimes just E. It does have a charge of -1, and when we get into ions and isotopes, you'll start understanding what that means. Its mass is very, very, very small. Sometimes it's rounded to a 0, so don't be surprised if you'll see it as 0, but it's approximately 1/1842 AMUs. AMU stands for atomic mass unit. They're so small they can't even use the same things like gram that we can use. And it's located in that electron cloud. That's that outside portion of the electrons. Next is proton, abbreviated with a P with a plus symbol. It has a charge of +1. And again, when we start talking about charged atoms, ions in particular, you'll start understanding what that +1 means. It does have a mass of 1 AMU. So if you think about it, if an electron is 1 over approximately 1,842 AMUs, then it would take about 1,842 electrons to equal 1 proton. That's how small these electrons really are. We can actually find the protons located in the nucleus. That's in the very center of the atom. Inside that nucleus, we also have the neutron. Notice its first 5 letters are NEUTR. That would be the first letters of neutral, which means no charge. You do often see it abbreviated as N or N with a exponent of 0, just to show that it has no charge. It does not affect the atom over there overall. But it is what gives us our isotopes, so we'll get into that very soon. Notice it's about the same size as a proton. Again, your protons and your neutrons are large when compared to the electron. It is also located in the nucleus. Those are the 3 basic subatomic particles that you need to know. You need to know the symbols, you need to know the charge, the mass in AMUs, and where it's located.